In chapter 10, you may remember that the really only thing that wasn't on the reference sheet was that relationship between the scale factor and the ratio of the areas. Remember, you had to memorize, you had to think about how area is a square unit measurement. Remember how I kept stressing that. So before I used scale factor to talk about area, we took that scale factor and we squared it. In this chapter, we've been talking about surface area, which does have to do with the three-dimensional figure, but remember, I stressed to you, that's still a two-dimensional square unit measurement. So just like in last chapter, when we took the scale factor and we squared it to talk about area, we would still take that scale factor and square it to talk about the surface area of similar figures, similar solids. So if I'm talking about the volume of them, it should just follow naturally that you would take the scale factor, and since volume is a cubic unit measurement, you're going to do what to the scale factor? Cube it, yes. So if the scale factor is A over B, then the ratio of their volumes would be A cubed over B cubed. And we're starting off simply just looking at figures, looking at their dimensions, and identifying whether these figures are similar. So in problem 1, part A, are the figures similar? Yes or no? Are their dimensions proportional? Remember, is what you're being asked. Yes or no? Okay, we haven't dealt with similar figures in a while. Let's refresh our memory. What you're checking for is 3 over 4, for example, equivalent to what over what? 8 over 10. And is that equivalent to what over what? 5 over 7. And some of you right away already realized that the answer is no, they are not similar because they're not proportional. In part B, are those proportions, are those dimensions proportional? Yes, they are. If you're not seeing it, this is what we're checking. Is 10 over 15 equivalent to 4 over 6 and equivalent to 6 over 9? And it is. The second part of the question is, what is the scale factor? Well, we wrote the scale factor 3 times. We just have to reduce it. What is the scale factor? 2 over 3. There it is. And we do have a couple of your turns. In the interest of using our time most productively, I'm going to do 2 problems first, and then your turn 2 problems, and then my turn, and then your turn on the back. So in problem 2, again, we're skipping the first your turn. You'll come back to it momentarily. In problem 2, notice I'm given the volume of these figures. I'm asked to find their scale factor. What do? Think back to what I said at the beginning. If I know the scale factor, what do I do to it to talk about volume? I cube it. I know the volume. What will I do to go backwards? Not square root, cube root. Yes. So I take these volumes and take the cubic root of them. Cubic root of 3375 is 15. And the cubic root of 1728, I'll answer that question, I'm not ignoring it, I promise, is 12. But of course, we're in a high school classroom, and when I look at that fraction, I realize it reduces. So of course, I reduce it, and I get what? 5 over 4. Beautiful question. Because of the order in which they gave it to me, this is on top, this is on bottom, I'm putting them that way. For all practical purposes, to be honest, the question doesn't really state how it wants it, so I really wouldn't have much of a leg to stand on to say, nope, you are wrong. But in general, yeah, we go left to right, top to bottom. Good on this screen. Okay, hold up your calculator. Show the class. If you have a calculator like that, it doesn't matter if yours is a different color, it's the same exact idea. The caret button is the button that looks like this. That's the button that you use to take a number to a power. If you look just above it, you'll see a function that looks like this. That's the function that allows you to take any root of a number. What you need to be mindful of is that you have to enter into your calculator the root that you want before you hit that function. So you would be typing into your calculator 3, and then second, and then the caret button, and then whatever number you're taking the cubic root of. And then I'll be coming around to make sure that you know how to use your calculators while you're working through the Your Turn Problem 1 and Your Turn Problem 2. Your Turn Problem 1 is not a Centio question. Your Turn Problem 2 is. So when you find the answer to the Your Turn Problem 2, please key it into the Centio. Yes, sir. Yes. And some of you didn't reduce the fraction, but your heart's in the right place. 2 over 3 is the scale factor. What you're doing is taking, and I loved that someone asked me, oh, this one is dealing with area, so I'm not going to cubic root it like I did in the one that you did, Mrs. Clouse. I'm just going to square root it like we did last chapter. Absolutely. Square root of 144 over square root of 324 equals that 12 over 18 that someone entered because they forgot to reduce a fraction. You still know what you're doing. The 1/2, I would guess maybe someone reduced a fraction. Oh, you answered the wrong thing here. All right, and then coming back here just to make sure that we're all on the same page. The scale factor for this is not 1/2. The ratio of the dimensions is 1/2, but you want to be really careful. It's a common mistake. Be really careful. Scale factor is a ratio of corresponding sides. The scale factor, I took 6 over 5 or 12 over 10. That's it. That's the scale factor. Once again, left to right is generally how we see it. Oh, and it does say, notice, first figure to second. I do have a light. Mm-hmm. Absolutely, which would reduce to. There we go. Yes, ma'am. Let's come over to that. In part B, it's asking, are any two square prisms similar? If they're talking about 2 cubes, I would say yes, definitely. Because let's say the dimensions of one cube are 2 by 2 by 2, and the dimensions of another cube are 3 by 3 by 3. No matter how I make that bigger or smaller, those dimensions are all going to be the same. So let me scratch that. Forget the numbers. The dimensions of this would be A by A by A. The dimensions of this would be B by B by B. The scale factor would be the same. Okay. Now in problem 3, just like what we did in chapter 10, we're using that scale factor. We're using that ratio of those similar figures in order to either find area or find volume. In problem 3, we're given the volumes, and we need to use that to find surface area. So think back to problem 2. When we knew the volumes, how did we work backwards to find the scale factor? We took the cubic root. Okay, so some of you might be keying into your calculator and taking the cubic root of 40 and taking the cubic root of 135, and then you're cringing. Why? Why are you cringing? Because, well, no, you're cringing because the cubic root of 40 is yucky, and the cubic root of 135 is also yucky. But if you take 40 over 135 and reduce it, we get 8 over 27. And when you go to take the cubic root of those numbers, it's much friendlier. Whoa! Thank you for bringing that up, though. Okay. What Austin said was, can't I just do 40 over 48 equals 135 over x? Do we see that that's not going to work? Because 40 and 135, those are cubic unit measurements of something, whereas this is something squared. Remember, a over b and a squared over b squared are not equivalent fractions. You got to be really careful of that. You need to find the scale factor. There's no shortcut way around it. I promise I'm not just making more work for you. Okay? You have to find the scale factor so that you then square it and that's the ratio that you would then use in a proportion to find the surface area of the larger solid. On the other side of the equal sign, when I have 4/9 equal to an x and a 48, where's the x? On top or on bottom? X is on the bottom with the 48 on top. I lost someone, so let me pause. Where did I lose you? I took the scale factor and squared it because I'm using scale factor to find area. Remember, area is a square unit measurement. So that's why we have to take that scale factor and square it. We've cube rooted it. We cube rooted the volumes so that we can find the scale factor. And then we take that scale factor and square it in order to put it into a proportion. And when you do, you find that the surface area is 108 square inches. Yes, ma'am. Because think back to chapter 7. I know it was a while ago. But way back in chapter 7, when we talked about similar figures, what was the definition? That their sides were proportional. And so the same idea applies here. Their surface areas are proportional, and their volumes are proportional. Yes, ma'am. Because you're talking about two completely different measurements. Surface area and volume, there's no direct correlation. If the surface area of one is, hopefully I didn't mess up my calculation somewhere along the way. I got it. You got that? Okay. Yeah, you can't think that if the volume of one is getting bigger, then is bigger than, let me backtrack, say that again. If the surface area of one is bigger than the volume of the other, there's no direct relationship like that. What you're looking for is just that you're setting up your proportion consistently. Small over large equaling small over large. I think you're overthinking it. Are we good on this screen? Okay. Before you go forth and do your turn problems 3 and 4, let's take a look at our do together problem 4. We can use these scale factors to find capacity of three-dimensional figures. And by capacity, I'm talking about, for example, in problem 4, we're talking about how many paper clips fit in a box. We could talk about the weight of something. They have that same relationship with volume. Okay, so in problem 4, what's happening? I have a small box that holds 220 paper clips. I have a large box that is formed by doubling the dimensions of the small box. Let me stop reading real quick. What's my scale factor? What's my scale factor? 1/2. And that's the word that tells us that. You want to be really careful about not missing something like that just by reading. Yes, ma'am? Tomato, tomato. Yes, as long as you set up your proportion consistently, you're fine. Well, if it makes your heart happy, I'll set up the proportion both ways. We'll end up in the same place at the end. Okay, sir.
If you're finding the amount of volume of paper clips inside a box, then you're saying that you just use double and 8 times the value of the paper clips.
And that's exactly what's going to happen, yes. Because this scale factor is 1/2, or 2/1. If I'm trying to find the capacity of my new box, I'm going to cube my scale factor. And that'll give me 1/8, or 8/1. However you want to think about the scale factor, we'll end up in the same place, I promise. No, I'm doing this. This is Casey. This is me making Casey happy. Whatever works for you.
So if it said like tripling,
your scale factor would be 1/3 or 3/1. And then we're setting up a proportion. Our old box fit 220 paper clips. I'm trying to find out how many paper clips will fit in my new box. And as you're noticing, we'll end up in the same place. To answer the question in a different way, Casey. Here, my scale factor is not what I'm actually asked for. My scale factor is a means to an end. Okay, so if I'm using 1/2 or if I'm using 2/1, it doesn't matter as long as I'm ending in the same place. Whereas, where was it? I lost it. Whereas back here, Casey, my scale factor was my end game. That's what they wanted. And they asked it of me in a particular order. That's why 5/6 would have been wrong here. But in the other problem, it makes no difference how you think of it. Hold on a second. Have I answered your question? Where are we confused? Because the new box is double the dimensions of the old box. So if the dimensions of the first box are 1, it doesn't matter. It's double.
How are you supposed to double a number you don't have?
Does it make sense
Could it be like, could you say like 2 over 4?
if it makes your heart happy? Do you see that you still end up in the same place, Jesse? Okay, are we good? Because the problem says double it. You're doubling the dimensions, which means the capacity is actually increased by 8. Okay. All right. Actually, we don't have time for the your turns to be centilloed, but I want to make sure that you have enough time to get into your notes what you need. The work for those your turns are on the screen. The your turn problem 3 work is on the screen, and then I'll change the screen for the your turn problem 4. This is upside down. Are we ready to change the slide? Not yet. Yeah, the your turn problem 3 is what's on the screen right now. Okay, because I'm trying to find out how many people can fit where. Inside the bulb. Can I change the slide now?
Yeah.